Okay, so this is how we are going to start with that the first unit. Already we have started, and the contents that the three only contents are there, bits are there, but in that the sub classification is also there. So we are right now the focusing on the SCR. Then we are going to learn the triac and then diac. So all these three devices are from the thyristor family. So what is thyristor? It is the next version of transistor. Got it? The transistor. So and the diodes earlier one. So how this thyristor family is there, and the details of that, the overview in the last session we have seen that, and few of the introduction of this SCR we have seen. So based on that, a few questions I just put for you. So if you are remembering, if you have noted down, so please just put the answers for these four questions in the chat box. So just for we will wait for 1 minute and we will just get that the answers for these questions. Otherwise the answers are here, don't worry, but this is the basic for the SCR. So next part whatever it is there, so it is depending on this only. So I will get the message over here, that is the okay, I got the answer. 4 layer reverse bias, okay, very good. So how many normal ways to turn on the SCR? So let us, we will see that. Notification, what is this? SCR is a 4 layer power device. In reverse blocking mode, junction J1 and J3 are the in reverse bias, and which pin provides the control. So for that, I didn't get the answer till now. Which pin provides control on SCR? So what is this? So the answers are here. That is normal way is to just make it on, that is the by two ways are there. Then it is a 4 layer device, and when it is a reverse mode, so that time J1 and J3 junctions are in reverse bias, and gate is the pin which can control the SCR, which can control the SCR. How it is going to be controlled? Because the SCR stands for silicon controlled rectifier. So the rectification is what? So it is just transforming or converting AC into the DC. But what is the meaning or the function of controlled word? That is, if you are remembering the half wave rectifier, so that is doing the conversion for the positive half of the AC cycle. Yes, the positive half, then for the negative half it is off, then again positive half, like that it was giving the output. But in that also, whatever the positive half total it is giving in the output, but if you want the part of that only, that is controllable. Okay, 45 degree, after 45 degree or after 90 degree, if you want to get just the output, so that can be done with the help of this SCR, and that is what the name is given, silicon controlled rectifier. So the various applications of thyristors. So this is the family. The applications are there for the SCR normally. That is the they have given in general. That is the bike regulator. That is as a switch main. If you are looking for the base, so it is the working as a switch. So how it is going to be used in a cameras? So what the camera, how it works, all we knows that when we click the button, so the shutter opens and get it closed. So at what time shutter should open, for what time shutter should be opened, and after how much time it should get off. So that is done by this particular thyristor family or the SCRs. So normally it is going to be used over there. Then fan heater, that is when the temperature goes below that particular temperature, so that heater should be get on. So that as a relay also it is going to be used. Then the SMPS, that is a simulated this uninterrupted power supply. So there also switched mode power supply, it is SMPS. So for uninterrupted power supply also, when the main AC supply goes off, so that time the UPS power should reach to that particular device to uh, avoid the damage to that device. So that work is going to be done by this particular SCR. So if you are looking the thyristor here, the symbol it is they have shown. So this is what the symbol we have seen for the SCR. That is, it has the three terminals: anode, cathode, and gate. So these are the few applications they have shown. In addition to that, if you are looking at a left side, triac, the applications of triac they have shown over here, so which we are going to study afterwards. But this is the slide combined was there, so I have put over here. So this is what we have seen yesterday, that is biasing of SCR. So you have to just watch these all three diagrams, and you have to put in the chat box that uh, three modes are there. So from that this diagram it is clear, but this figure A is for what, figure B is for what, and figure C is for what. So that I am expecting from your side. So I can take a one of minute and try to tell if you have noted down yesterday, so that will be easy. But if you are not noted, so you supposed to recall that की अरे हा मोड कुठला आहे किंवा हे ह्या बायसिंगला काय म्हणतात, that you supposed to remember and put in a chat box. So if anyone remembers, so just give the quick answer so that we will go ahead, and the others also can follow the same. You first you supposed to just check that the biasing की कुठली पिन कुठं जोडलेली आहे, कशी जोडलेली आहे, आणि त्यानुसार थ्री मोड्स वी हॅव डिस्कस्ड yesterday. आणि प्रत्येक मोड मध्ये काय होतं, वन्स अगेन आय विल जस्ट गिव्ह द ब्रीफ. So anyone has put the comment? Okay, nice. The response comes. Okay, I will explain over here. So figure A. So what is done here? That is, anode is connected to negative and cathode is connected to positive. So itself it is telling that it is a reverse. So the name for that is reverse blocking mode, because P is connected to negative and N is connected to positive. So reverse blocking mode. So in this mode, whether the SCR will be on, the answer is no, because the in this mode or biasing, J1 junction and J3 junction both are in reverse bias, and due to that no possibility of flow of the current, and this is what reverse blocking mode is. If you are going for the diagram or the figure number B, so in this the opposite case is there, that is anode is connected to positive of the battery and cathode is connected to negative of the battery. That means the forward blocking mode. So why forward blocking mode? So with reference to figure C, we are going to learn that. First we will see for figure B. So in this mode, junction J1 and J3 will be in forward bias. J1, J3 will be in forward bias. But at the same time, J2 will be in reverse bias. J2 will be in reverse bias. And as the current is nothing but flow of electrons. So it has to just pass from one end to other. But as the J2, the center junction, it is in a reverse bias, it cannot allows the electrons to move across it. And that's why the name is here forward blocking mode. Forward blocking mode. Even though the forward biasing is there, but it blocks the current. That is forward blocking mode. So this is the figure B. At the same time, if you are modifying the figure B as figure C, if you are looking figure C, so here the anode is connected to positive, same as that figure B, and cathode is connected to negative, same as B. But additionally, what they did is that they have given the gate voltage, or they have supplied the gate current by using this biasing. What is this biasing? As the gate is always P, that is positive, so it is been connected in a forward bias, that is P is connected to positive of battery and the negative is connected to cathode. That's why the gate is in a forward bias, gate to cathode, and it will provide some current. That is called gate current Ig. Just note it down, this terminology also. Gate current Ig. And this Ig is making this particular SCR to be goes in or to become on. To become on. So this is the third mode, that is the figure C, which is known as the forward conduction mode. Forward conduction mode. Got it? So in this mode, the SCR will be on. Now, some more things about this mode, forward conduction mode. That in this, a pulse of gate current is required. Just listen carefully. A pulse means a short duration. A pulse of gate current is required to turn on the SCR. Once the pulse is given, the SCR will be on, and after that, you can disconnect this gate battery. Whatever this, the if you are looking the cursor, so this we can remove. No use of this particular. Only for giving the trigger, it is required. So SCR will be get turned on and it will be remain on. Till what? So there are few methods of making the SCR on and SCR off. तुम्ही म्हणताल की गेट करंट दिलाय, SCR ऑन झालाय, मग गेट करंट बंद केला की SCR ऑफ होईल, तर तसं नाही. So it is just used as a trigger to make the SCR on. मग SCR off कसा करायचा? So the various methods are there to make it switch off, and that we are going to learn in the coming slide. So all of you got about this, the brief what we have seen in last session. So this is what we stopped over here, that is the VI characteristic. So this is very important to understand the VI characteristic of SCR. So which terminologies are being used over here? So read it once, then we will have here the discussion on that. कुठल्या कुठल्या टर्म्स आहेत त्या वाटल्यास नोटबुक मध्ये लिहून घ्या. दॅट इज फॉरवर्ड ब्रेक ओव्हर व्होल्टेज, ही एक टर्म आहे. होल्डिंग करंट, ही एक टर्म आहे. देन मॅक्झिमम रिव्हर्स व्होल्टेज, VBR, त्याच्यामध्ये परत R म्हणजे ब्रेकडाऊन, रिव्हर्स ब्रेकडाऊन व्होल्टेज असं ते त्याचं नॉमिनेशन आहे, रिव्हर्स ब्रेकडाऊन व्होल्टेज. So always whenever we are learning any electronic device, the main important part is the VI characteristic. VI characteristics means what? The input output response. की काय इनपुट दिल्यावर आउटपुट कसं मिळतं, दॅट इज द बिहेवियर ऑफ दॅट Okay, sorry for the interruption because that network problem was there. So thank you, Sir, that she recalled me. I got the message over here. So we went up to what point you listened, I don't know, but just I will repeat the VI characteristic. So this VI character, is it audible right now?
Yes, sir.
Okay. So VI characteristics, I will just repeat. So this VI characteristics is just explaining the input-output response of any device.
So screen is not visible.
Just a minute. Present recording is going on. Now is it?
Yes, sir.
Thank you. So VI characteristics of any device is representing the response of input and output with that device. So here it is the diagram for SCR VI characteristic. So if you are looking, this is the, if you are making the four quadrant of this particular graph. So first, second, third and fourth. So the response is in only first and third quadrant, in which if you are looking for the x-axis and y-axis, so it is the response of input voltage versus output current. Input voltage versus output current, that is VAK and IA. So VAK is nothing but anode to cathode voltage, and IA is nothing but the current which can flow through the SCR. That is anode current, like that they have given the name. So as we have seen, in three ways or three biasing methods are there through which we can bias the SCR. So from that, the two, that is forward blocking and forward conduction. So they are related with first quadrant. Forward blocking and forward conduction. So what is forward blocking? फॉरवर्ड ब्लॉकिंग मध्ये काय होतं तर VAK देत जातो आपण. VAK means anode to cathode voltage we are increasing, but that time the current whatever it is going on, so it is not going to flow through the SCR. म्हणजे IA जो आहे तो वाहत नाही, कारण that is what we have seen over here की फॉरवर्ड ब्लॉकिंग मध्ये जरी हे व्होल्टेज वाढवत गेलं तर J2 हा रिव्हर्स बायस मध्ये असतो, त्यामुळे करंट फ्लो होत नाही. बट ॲट वन इन्स्टंट इट क्रॉसेस द VFBO, म्हणजे त्याची एक लिमिट ठरवलेलं असतं की ब्रेक ओव्हर व्होल्टेज. ते जर क्रॉस झालं म्हणजे त्या लिमिटच्या वर व्होल्टेज गेलं की करंट सडनली चेंज होतोय. करंट होल्डिंग करंट पेक्षा जास्त गेला की SCR हा ऑन होतो. म्हणजे जसं आपण म्हणलं की फॉरवर्ड ब्लॉकिंग मोड मध्ये SCR ऑन होत नाही, परंतु एक्स्ट्रीम केस की जर VAK तुम्ही वाढवत गेलात आणि VFBO च्या वर गेलं व्होल्टेज, तर त्यावेळेस SCR ऑन होतो. बट दॅट विल डॅमेज द SCR. That will damage the SCR. So that is the case for forward blocking. मग फॉरवर्ड कंडक्शन काय? तर तुम्ही हे व्होल्टेज वाढवत गेलाय आणि त्याचबरोबर गेट करंट पण अप्लाय केलाय. म्हणजे फिगर नंबर C. फॉरवर्ड व्होल्टेज वाढवत गेलाय आणि त्याचबरोबर इथं गेट करंट पण अप्लाय केलाय की ज्याच्यामुळं हा J2 becomes the forward bias. J2 junction becomes the forward bias. मग त्यानं काय होतंय तर हे ब्रेक ओव्हर पर्यंत जातच नाही, त्याच्या आतमध्येच करंट हा वाढतो आणि होल्डिंग करंट पेक्षा जास्त करंट झाला की SCR तुमचा ऑन होतो. तेच जर तुम्ही गेट करंट अजून वाढवलात तर अजून एकदा तो होल्डिंग करंट पेक्षा लवकरच जास्त होतो आणि SCR ऑन होतो. म्हणून हे डॉटेड लाईन आणि इथं दाखवलेले आहेत IG2, IG1 आणि IG0. And the condition is IG2 is greater than IG1 greater than IG0. तर हे झालं फॉरवर्ड ब्लॉकिंग आणि फॉरवर्ड कंडक्शन. IG दिला की फॉरवर्ड कंडक्शन. हे झाले दोन मोड. द थर्ड मोड दॅट इज रिव्हर्स ब्लॉकिंग. रिव्हर्स ब्लॉकिंग म्हणजे निगेटिव्ह व्होल्टेज देत जायचंय. VAK मायनस मायनस देत गेलात. त्यामध्ये सुद्धा एक लिमिट येते, दॅट इज कॉल्ड VBR, दॅट इज ब्रेकडाऊन व्होल्टेज रिव्हर्स. So if your this negative voltage crosses this reverse breakdown voltage, so that time also current suddenly flows in a reverse direction, so that is known as a reverse breakdown, which is harmful for SCR, so we cannot give the more this VBR, that is the breakdown voltage. We supposed to just keep it in a limit. So like this is the VI characteristics of SCR in 3 biasing mode. Now just excuse the few parameters related to this VI characteristic: latching current, holding current, conduction angle, surge current rating, like that. So what is this latching current? तर जसं आपण म्हणलं की SCR ऑन कधी होतो, की एनोड टू कॅथोड फॉरवर्ड बायस मध्ये द्यायचा, गेट पल्स द्यायची, SCR झाला ऑन. त्यानंतर गेट पल्स काढून घेतली, पण कारण कंडक्शनसाठी गेट पल्सची काही गरज नाही. द SCR विल बी रिमेन ऑन. मग त्यानंतर मिनिमम किती करंट असला पाहिजे की जेणेकरून SCR ऑनच राहील? सो दॅट करंट इज नोन ॲज लॅचिंग करंट. And the typical value for SCR, that is the 25 milliampere. So that is a fixed one, so you're supposed to be remember, as it may ask in the MCQs. So next parameter is holding current. So holding current is what? The minimum anode current below which SCR will be goes in blocking mode, that is off. Holding current, if you are remembering this particular diagram, so here holding current IH, so this is the minimum current. त्याच्या वर करंट गेला की SCR ऑन, त्याच्या खाली करंट आला की SCR ऑफ. हा एक कन्सेप्ट लक्षात ठेवा, बिकॉज फॉर टर्न ऑफ द SCR that we are going to use. So this is what the holding current, the minimum current. And for SCR, it is typical value is 10 milliampere. 10 milliampere. Then the next one, that is the conduction angle. The conduction angle is nothing but the duration for which the SCR is on. आता अँगल तुम्ही म्हणताय आणि इकडं ड्युरेशन पण म्हणताय, म्हणजे टाइम. सो अँगल अँड टाइम आर कोरिलेटेड. जर तुम्ही इनपुट व्होल्टेज जर साइन वेव्ह दिली, विच कन्सिस्ट ऑफ पॉझिटिव्ह निगेटिव्ह, तर त्याच्यामध्ये अँगल वापरला जातो. अँड इफ यू आर प्रोव्हाइडिंग द DC सप्लाय ॲज अ इनपुट, सो दॅट टाइम इट इज द ड्युरेशन इज नोन ॲज. गॉट इट? कारण साइन वेव्ह जर तुमच्या डोळ्यासमोर आणलीत आणि त्यातले मग 90 डिग्री, 180 डिग्री, 45 डिग्री, 135 डिग्री, so that is known as the angle. की 180 मधला 90 degrees SCR on होता असं, that is known as the angle. But if you are looking for DC supply, so that time the duration will come for 10 second or the 5 second, like this. This is the what? Duration, conduction angle. Surge current rating. So surge current rating is again the parameter related to current, that is peak anode voltage, म्हणजे maximum anode voltage that SCR can handle for normal operation. म्हणजे विदाउट डॅमेज होता नॉर्मल ऑपरेशन जर मॅक्झिमम किती करंट तो सहन करू शकतो एनोड करंट, that is the surge current rating. So that is also might be vary with device to device and manufacturer to manufacturer. कारण तुम्ही कॉम्पोनंट कुठले वापरता आतमध्ये. आता नॉर्मली तुम्ही म्हणाल की मग रेजिस्टर कॅपॅसिटर हेच वापरलेले असणार. येस, बट इन दॅट ऑल्सो देअर सम स्पेसिफिक रेटिंग्ज आर देअर. की क्वार्टर वॅटचा वापरलेला आहे, हाफ वॅटचा वापरलेला आहे, त्याचं सिंक करंट, सोर्स करंट हे वेगवेगळे आहेत. तर त्याच्यानुसार हे रेटिंग बदलत जातं, सर्ज करंट रेटिंग. So for that, you supposed to recall the concept from logic family, which you have studied in a digital techniques. लॉजिक फॅमिली एक होता बघा. त्याच्यात हे सिंक करंट म्हणजे काय, सोर्स करंट म्हणजे काय, सिंक व्होल्टेज, सोर्स व्होल्टेज. सो ऑल दॅट पॅरामीटर्स आर व्हेरी इम्पॉर्टंट whenever we are talking about electronic devices. So this is what the parameters. So few more parameters are here, that is IGM, VGM. म्हणजे गेट करंट आणि गेट व्होल्टेज. दॅट इज द पिक, म्हणजे मॅक्स गेट करंट, मॅक्स गेट व्होल्टेज. सो लार्जेस्ट अमाऊंट ऑफ करंट और व्होल्टेज दॅट कॅन बी अप्लाइड टू गेट व्हाईल इन कंडक्शन मोड. म्हणजे गेट करंटला पण एक लिमिटेशन असतं की किती गेट करंट तुम्ही देऊ शकता मॅक्झिमम. सो दॅट इज डिसाइडेड बाय दिस पर्टिक्युलर IGM आणि VGM. Next parameter is di by dt or dv by dt. म्हणजे change in current with respect to time and change in voltage with respect to time. So this is the critical rise on state current oblique voltage. म्हणजे जर तुमचा डिव्हाइस चालू आहे तर त्याच्यामध्ये सडन करंटमध्ये राईज होतीये किंवा सडन व्होल्टेजमध्ये राईज होते, तर तो किती सहन करू शकतो तो डिव्हाइस. सो दॅट इज व्हॉट दिस रेटिंग इज, DI बाय DT किंवा DV बाय DT. दॅट इज क्रिटिकल राईज ऑफ ऑन स्टेट करंट ऑब्लिक ऑन स्टेट व्होल्टेज. So this is the parameter. Next parameter is TGT. म्हणजे गेट ऑन टाइम, टर्न ऑन टाइम. म्हणजे ज्यावेळेस तुम्ही गेट करंट देता त्यानंतर काही मिली सेकंदनी तो SCR ऑन होतो. तर तो जो ड्युरेशन आहे, सो दॅट इज नोन ॲज द TGT. टाइम इट टेक्स फॉर अ गेट पल्स to send the SCR into conduction mode. म्हणजे गेट करंट दिल्यानंतर किती वेळानं तो SCR ऑन होतोय, सो दॅट टाइम इज नथिंग बट गेट टर्न ऑन टाइम SCR साठी. देन नेक्स्ट इज TQ, SCR टर्न ऑफ टाइम. दॅट इज द टाइम इट टेक्स फॉर SCR टू स्टार्ट ब्लॉकिंग करंट. म्हणजे बंद व्हायसाठी, ऑन पासून ऑफ पर्यंत जाण्यासाठी त्याला किती वेळ लागतो, तो टाइम म्हणजे टर्न ऑफ टाइम, दॅट इज TQ. आणि कसं हे बंद केलं जातं ते पण आता इथं हिंट दिलेली आहे की आफ्टर एक्सटर्नल व्होल्टेज स्विच टू निगेटिव्ह सायकल. म्हणजे AC सायकल जर घेतलं, AC इनपुट, तर पॉझिटिव्ह निगेटिव्ह हाफ सायकल असतात. तर त्यातली निगेटिव्ह हाफ सायकल आली की रिव्हर्स व्होल्टेज मिळतं. रिव्हर्स व्होल्टेज मिळालं की तो SCR ऑफ होतो. सो दॅट इज द फर्स्ट मेथड ऑफ टर्न ऑफ SCR, की जे आपण पुढे बघणार इन डिटेल. पण आत्ताच ह्या TQ पॅरामीटरमुळं इट कम्स इन अ पिक्चर. दॅट इज टर्न ऑफ टाइम म्हणजे काय, तर ऑन पासून ऑफ मध्ये जाण्यासाठी जेवढा वेळ लागतो त्याला टर्न ऑफ टाइम म्हणतात. अँड द लास्ट पॅरामीटर इज TJ. So this TJ is nothing but junction temperature. म्हणजे ज्यावेळेस SCR ऑन होतो त्यावेळेस डेफिनेटली द इंटरनल कॉम्पोनंट्स आर गेटिंग हिटेड. सो दॅट टाइम whatever the maximum temperature it can sustain for a normal operation, that is the temperature range which the SCR may operate without damage. म्हणजे विदाउट डॅमेज न होता तो किती टेम्परेचर सहन करू शकतो, सो दॅट टेम्परेचर इज नोन ॲज द TJ, दॅट इज जंक्शन टेम्परेचर. अगेन इट इज डिपेंडिंग ऑन द मॅन्युफॅक्चरर. मॅन्युफॅक्चरर वेगवेगळे, आता SCR हे वेगवेगळे मॅन्युफॅक्चरर तयार करतात. मग ते ज्यावेळेस जंक्शन तयार करतात त्यावेळेस जे मटेरियल वापरतात तर त्याच्यानुसार की ते जंक्शन किती टेम्परेचर पर्यंत सस्टेन करू शकतं ते ठरवलं जातं. आपण म्हणणार की हा आता रूम टेम्परेचर 25 डिग्री 27 डिग्री, सो दॅट इज ओके, बट व्हॉट एव्हर द ऍक्च्युअल इज देअर, की जर मिलिटरी मध्ये जर हे कॉम्पोनंट वापरले SCR वगैरे, तर मिलिटरी ऍप्लिकेशन्स म्हणजे डिव्हाइसेस जे असतात they are working in a very unnatural conditions, that is in the 50 degree as well as in a Antarctica like minus 50 degree also. So that time these devices should work. तर किती टेम्परेचर पर्यंत हे वर्क होऊ शकतात, सो दॅट इज डिसाइडेड बाय दिस पर्टिक्युलर TJ factor or the parameter, and which depends on a material which is used for the construction or the manufacturing. त्यामुळे प्रत्येक मॅन्युफॅक्चर एक डेटा शीट दिलेली असते प्रत्येक कंपोनंट सोबत, तर त्या डेटा शीटमध्ये हे सगळे पॅरामीटर्स नोंद केलेले असतात. जसं की आपण मागच्या स्लाइडमध्ये बघितलं की होल्डिंग करंट, लॅचिंग करंट, सो दे आर ऑल्सो द फिक्स वन, बट इट इज गिवन बाय द मॅन्युफॅक्चरर ओनली. Got it? So this is what the parameters related to the SCR. Now, in short, we will just look out for the SCR turn on method. की SCR ऑन कसा करायचा, ऑलरेडी आपण शिकलेलो आहोत बायसिंग मध्ये, की नॉर्मली देर आर द टू वेज. आपण क्विज मध्ये एक क्वेश्चन विचारला होता की नॉर्मली किती प्रकारे आपण SCR ऑन करू शकतो. तर नॉर्मली टू वेज, बट हियर दे हॅव प्रोव्हाइडेड द व्हेरियस डिफरंट वेज ऑल्सो, सो दॅट ऑल्सो यू कॅन कन्सिडर. मग हे काय काय आहेत, तर फर्स्ट जे मी आन्सर लिहिलते की दोनच वे आहेत, तर ते दोन वे कुठले आहेत ते मी पहिल्यांदा तुम्हाला सांगतो. सो फर्स्ट इज द फॉरवर्ड ब्लॉकिंग मोड. फॉरवर्ड ब्लॉकिंग मोड, त्यामध्ये तुम्ही एनोड टू कॅथोड व्होल्टेज फॉरवर्ड बायसिंग देत गेलायत, परंतु एका लिमिट नंतर म्हणजे VBR ब्रेक ओव्हर व्होल्टेज नंतर तो SCR ऑन होतो. सो दॅट इज द वन मेथड विच इज हजार्डस बट फॉर SCR. आणि सेकंड काय, तर एनोड टू कॅथोड व्होल्टेज फॉरवर्ड बायस करायचं आणि गेट पल्स द्यायची, SCR ऑन होतोय. So they are the regular two methods for making the SCR on. But besides that, a few are listed over here. So let us see one by one. So first is forward voltage triggering. So this is the same as that of my forward blocking mode. म्हणजे फॉरवर्ड व्होल्टेज देत जायचं आणि ते ब्रेक ओव्हर व्होल्टेजच्या वर गेले की SCR ऑन होईल. सेकंड इज गेट ट्रिगरिंग. एनोड टू कॅथोड तर फॉरवर्ड बायस पाहिजेच, प्लस गेट पल्स दिली की SCR ऑन होतो. सो दॅट इज गेट ट्रिगरिंग. थर्ड वन इज रेडिएशन ट्रिगरिंग, त्यालाच लाईट ट्रिगरिंग म्हणतात. आता काही काही SCR ला एक छोटीशी विंडो दिली जाते आणि त्या विंडोतनं तुम्ही त्याच्यावर लाईट पाडली की ते जे आतले जंक्शन्स आहेत J1, J2, J3, they will be operating in such a way that the SCR will become on. आणि त्याच SCR ला म्हणतात लाईट ऍक्टिव्हेटेड SCR और LASCR. तो नॉर्मली एज्युकेशनल फील्डमध्ये आपल्याला तर नाहीये कुठं बघायचा किंवा स्टडी करायचा, बट यू शुड रिमेंबर की असे पण SCR आहेत, लाईट ऍक्टिव्हेटेड SCR. त्यानंतर चौथी मेथड आहे ती थर्मल ट्रिगरिंग. थर्मल इन द सेन्स टेम्परेचर, की जंक्शनचं टेम्परेचर वाढलं की डिप्लेशन लेअर कमी होतो. डिप्लेशन लेअर कमी झाला की इलेक्ट्रॉन्स फ्लो होतात, इलेक्ट्रॉन्स फ्लो झाले की करंट वाहतो, करंट फ्लो होणं म्हणजेच SCR ऑन होणं. सो दिस इज व्हॉट द थर्मल ट्रिगरिंग इज ऑल्सो युज्ड समटाइम. That is, the width of depletion layer decreases with rise in the junction temperature. And if the anode is at near breakover voltage and the temperature rises, the device may start conducting. But this is very important statement. This is an undesirable triggering. दिस इज अ अनडिझायरेबल ट्रिगरिंग. नुसतं तुम्ही जंक्शनला टेम्परेचर वाढवलं की तो कंडक्शन मोडमध्ये जातो, परंतु इट इज अ अनडिझायरेबल. And last way of just making the turn on, that is a dv by dt triggering. dv by dt triggering म्हणजे immediately voltage वाढवायचं. That is the deviation in voltage with respect to time. The reverse biased junction of SCR may have the capacitance across it. And when a sudden voltage is applied, the device may get turned on. And this is what how this particular SCR will get turned on, and due to the capacitance charging. So in making turn off, we are going to learn that how the capacitor is been used in this SCR circuitry and in what manner it will work. So these are the few turn on methods for the SCR. So I hope till now whatever we have gone through, so you understand it. So go once again in 1 2 days the few notes also we are going to I will just put on that study material. So just request to all of you that just go through that the study materials by other subject teachers also, they have might be kept over there. If not, just ask them to just put the notes or the ebooks and other materials related to the subject on that. So that I hope that's I will give this responsibility to the CR, or anyone can just tell, no particular. Na? So to ask that respective subject teacher to put the notes and all other things over there. So today we will stop over here, and I will stop here. So you just put your attendance and you can leave. The other thing is that for elective subjects, so as per the your request, uh, I have prepared that list and provided to that respective subject teacher. So join these lectures now sincerely, give the attendance 100%. Thank you.